Hello everyone, my name is Haya Mahmoud. I'm 14 years old. I'm from Dubai National School and I'm in 10th grade. And today I'll be telling you all about Newton's first law. So first of all, what is Newton's first law? Newton's first law states that an object at rest will stay at rest and an object in motion will stay in motion with constant velocity unless acted upon by an outside force. Take this box for example. This box is currently at rest, and it will continue to stay at rest unless an outside force acts on it. For example, someone pushing the box. Newton's first law can also be called the law of inertia. Inertia is the tendency of an object to resist a change in its motion or to not accelerate. We can measure inertia using the mass of an object. So, if there is more mass, then we have more inertia, and if there is less mass, then there is less inertia. So if we want to describe Newton's first law in an equation form, we can say that all objects that obey Newton's first law have a net force that is equal to zero. Take this airplane for example. All the forces that are acting on the airplane are balanced forces, which means that the summation of all forces along the x-axis are equal to zero, and the summation of all the forces along y-axis are equal to zero, which will then give us the net force as equal to zero. We can also describe objects that obey Newton's first law as objects at equilibrium. When we say an object is at equilibrium, there are two cases. Either the object is at rest, or the object is moving with a constant velocity. But in either case, the net force is going to equal to zero. Okay, now let's take some practice questions. First, a truck is moving with a constant velocity of 10 meters per second. What is the net force acting on the truck? Recall that objects with constant velocity are at equilibrium and have a net force that is equal to 0 newtons. So the net force acting on the truck is going to be 0 newtons since it's moving with a constant velocity. A ball is at rest. Find the net force acting on the ball. Since the ball is at rest and objects at rest are at equilibrium and have a net force equal to 0 newtons, then the net force acting on the ball is also going to be 0 newtons because it is at rest. If an upward force of 340 newtons is acting on a rocket, then what other force causes the rocket to have constant velocity? In order to have constant velocity, that force has to equal to 0, which means that the summation of forces along the y-axis and the summation of forces along the x-axis have to equal to 0. So, if we have an upward force of 340 newtons, we need a downward force of 340 newtons. A bowling ball has a mass of 3 kilograms and is at rest. A baseball has a mass of 0.15 kilograms and is moving with a velocity of 20 meters per second. Which ball has more inertia? The measure of inertia is the mass of an object, so of course the bowling ball has more mass despite being at rest. Now let's take a question that we can actually solve. A traffic light is supported by two cables that are 140 degrees apart. Each cable exerts a force of 150 newtons on the light. What is the gravitational force acting on the light? And they told us that the object is at equilibrium. So first, let's draw a diagram that represents a traffic light and the forces acting on it. So this box or dot is going to represent our traffic light. And then this is the first force exerted by the first cable, which I'm going to call FC1. It's going to be 150 newtons. And then the second force, which is exerted by the second cable, I'm going to call it FC2, and it's also 150 newtons. Then of course we have the gravitational force, which is Fg, and it is what we need to find. And they also told us that the two forces are 140 degrees apart. Now let's draw our y and x axis. So this is the y axis, let's label that, and then this is the x axis, and let's label that as well. Now you can notice that the y-axis actually cuts between the two cables, which means that we can cut the angle in half and have this side equal to 70 degrees and this side equal to 70 degrees. Or you can do 140 divided by 2. Now, in order to find FG, we have to resolve FC1 and FC2 into components. So let's draw the components. So FC1 has a component lying on the positive y-axis and another component lying on the positive x-axis, while FC2 has a component lying on the y-axis, so the y-axis right here, and then another component lying on the negative x-axis. So now let's calculate the components, but actually we don't really have to calculate the components that are lying along the x-axis because FG is on the y-axis. So it would be unnecessary to calculate those on the x-axis. So now let's calculate the components. So I'm going to first find the component for FC1. I'm going to call it FC1y, which is equal to FC1 cosine of theta. And let's replace the numbers. So 150 cosine of 70, which is approximately going to be 51 newtons. And then let's do FC2. So FC2 is FC2y, which is FC2 cosine of theta. And we can do 150 cosine of 70 again, which is going to be 51 newtons. Now, let's recall that objects at equilibrium have a net force that is equal to 0, which means the sum of all forces on the y-axis and all the forces that are on the x-axis is equal to 0. So, we can write this in an equation form where sigma Fy is equal to the Fc1y plus Fc2y. And since they are in the opposite direction of Fg, we're going to do minus Fg. Now let's replace our numbers. So we know that sigma Fy is equal to 0. Fc1y and Fc2y, we already found them. They are 51 plus 51. And then minus Fg. So 51 plus 51 is going to give us 102 minus Fg, of course, equal to 0. And now let's add Fg on both sides. So we're going to have Fg is equal to 102 newtons. And let's add the direction. So Fg is going downward, so we can say downward, or you can say south. And this is how you find Fg. So now we are nearing the end of the presentation, so let's take a summary about Newton's first law. So first, we discussed what is Newton's first law. It states that objects that are at rest or moving with constant velocity stay in the same state unless acted upon by an external force. Then we said that Newton's first law is also called the law of inertia, and inertia is the tendency of an object to resist a change in motion. And we said to measure inertia, we have to take into consideration the mass of an object. And then we discussed that objects that obey Newton's first law are considered objects that are in equilibrium, which mean that the objects are either at rest or it's moving with constant velocity and they have balanced forces. And lastly, any object that's obeying Newton's first law, it means that the net force is going to equal to 0, and of course the summation of forces along the x and y axis are going to be equal to 0. And this is the end of the presentation. Thank you so much for listening, and I hope that you learned something new.